This small-scale plastic calendaring machine was conceptualized and built by Nick Beaver, Kyle Ekholm, Charles Theilman, and Callan Wright, with assistance from Dr. Jiang. This machine was requested by NDSU's plastic lab to work in tandem with the lab's existing plastic extruder. Calendaring is the process of smoothing and compressing a material, plastic in our case, by passing it through a number of heated rollers. Extruded plastic emerges as a flat film or sheet whose thickness is determined and made uniform by the gap set between two rollers. The objective was to create a machine for NDSU's plastic lab where they may create plastic samples for material analysis. With a background in the calendaring process, we began considering designs for a small-scale layout. The constraints we had to meet included progressive compression steps, which would require 3 or more rollers, variable roller speeds, a fine roller gap adjustment system, and adjustable roller temperatures. To achieve multiple compression steps, we decided that a 3-roller system would be sufficient, as it would allow for 2 levels of flattening. This decision was also influenced by a limited budget. The rollers are organized in an I formation, meaning that they are assembled vertically in relation to one another. To ensure that the rollers could operate at varying speeds, we chose to use a variable frequency drive, or VFD, paired with a 3-phase electric motor, both supplied by the NDSU Mechanical Engineering Department. Furthermore, the gearing from the motor to the rollers was reduced significantly, resulting in a slow overall rotation. The roller gap adjustment system utilizes a 20-to-1 worm gear assembly on top of a narrow-pitched thread inside the frame. This allows for very fine adjustments of the roller gap from 0 to a quarter inch. The variable roller temperature is powered by a heating element placed within an oil tank. This element heats up oil, which then circulates through the system with a dedicated pump. With the components chosen and a CAD model established, it was now a matter of constructing the machine. The construction process utilized welding, plasma cutting, drilling, cutting, and grinding. Various jigs and levels were used to ensure that the frame was square. Additionally, grease zerks were added to allow for smoother travel and operation of the adjustment system. At the time that this video was created, testing is still in progress. The VFD and electric motor have been proven to function at a large range of speeds, which satisfies one of the requirements. Additionally, the fluid pump and heating system have been shown to work as intended. A temporary setup was created to ensure that the fluid would flow sufficiently through the entire system. Now that this has been proven, more robust lines have been installed to the machine. These lines also add structural integrity so the rotary unions don't rotate with the rollers. The next course of action is to pair up the machine with the extruder to test its capabilities. We'd like to extend a thank you to American Roller for working with us and manufacturing the rollers to our specifications. Finally, we'd like to thank Dr. Jiang for his guidance throughout the project. And with that, thanks for watching.